Okay, indoor air pollutants. We're going to cover quite a few things here. So it's a long list, as you can see. So we just need to identify indoor air pollutants. And there's quite a few. Carbon monoxide is an indoor air pollutant that is classified as an asphyxiant. We'll cover that. Indoor air pollutants are classified as particulates that are classified as particulates include asbestos, dust, and smoke. Indoor air pollutants that come from natural sources, human-made, can come from natural sources, human-made sources, and combustion. Common natural source indoor air pollutants include radon, dust, and mold. So we'll cover these as well, especially radon. Common human-made indoor air pollutants include insulation, volatile organic compounds, yet again, from furniture, paneling, and carpets, formaldehyde from building materials, furniture, upholstery, and carpeting, and lead from paints. Common combustion air pollutants include carbon monoxide, nitric oxides. Of course, any combustion reaction creates nitric oxides, sulfur dioxide, particulates, and tobacco smoke. Radon 222 is a naturally occurring radioactive gas that is produced by the decay of uranium found in some rocks and soils. So that's an important one. It can infiltrate homes as it moves up through the soil and enters the homes via the cracks in basement or cracks in the walls or foundation. It's also dissolved in groundwater that enters homes as well. And exposure to radon can lead to radon-induced lung cancer, which is second leading cause of lung cancer in America. So an essential one for us to know about. All right. So developing and developed world, think about this in terms of its level of industrialization. Developing nations use more subsistence fuels such as wood, manure, and charcoal. And any combustion is going to create nitric oxides, but combustion of biofuels also creates carbon monoxide, volatile organic compounds, and particulate matter as well. And combusting indoors with poor ventilation leads to high concentrations of these pollutants. It's a scary fact: 3 billion people globally cook with subsistence fuels such as this, resulting in an estimated 3.5 to 4.3 million deaths annually over the long term, of course, and sometimes not. So something to keep our eye out for as well. But developed nations, it's slightly different. We use more commercial fuels, oil, coal, natural gas supplied by utilities, but this is burned in closed, well-ventilated furnaces or stoves. So this can create its own problems as well. The major indoor air pollutants in developed nations come from chemicals in products, adhesives in furniture, cleaning supplies, insulation, and lead paint. So, as we've said before in the previous video, feel free to pause and go back. You're creating an outline for the chapter readings that are coming after this. Particulate matter and asbestos. Particulates, remember PM 2.5 and 210, or 2.5 and 10. Common indoor air pollutants, smoke, indoor biomass combustion or cigarettes, dust, and asbestos. Now, what is asbestos? It's a long silicate particle previously used in insulation. It's been linked to lung cancer and asbestosis. We phased out the use of this, but a lot of buildings still have asbestos. That's why older buildings typically need to be inspected before any construction is done to it, or repairs are done to it, or it's demolished, because this can't just be left in here. It has to be removed by professionals. It's not dangerous until insulation is disturbed and asbestos particles enter the air as dust and such. And then they enter the respiratory tract. Trained professionals, again, with proper respiratory equipment, because this is very dangerous stuff when it is disturbed. And they use plastics to seal up the area from the rest of the building, etc. So it's an important thing to know about for sure. Carbon monoxide is essential. Every one of you should have a carbon monoxide detector in your home. The incomplete combustion of hydrocarbons creates carbon monoxide. Not all fuels combusted due to low oxygen or low temperature. It's an asphyxiant. Now, what does that mean? We have hemoglobin that carries oxygen and carbon dioxide within our red blood cells. But carbon monoxide actually adheres to this hemoglobin and blocks oxygen and carbon dioxide from the red blood cells. So in essence, you're suffocating. That's why we call it an asphyxiant. So it's lethal to humans in high concentrations. It's colorless and odorless. So the carbon monoxide detector acts in such a way that it will go off if it detects any. So because your senses are useless in determining if it's there or not. And so, especially with poor ventilation, this can be a problem. So you become delirious, you're unable to help yourselves. Eventually, you pass out, and then you don't get up. And that's the way carbon monoxide works. So in developed nations, it's released into the home by malfunctioning natural gas furnace ventilation, and it can be detected again by carbon monoxide detectors. Talk to your fire department about where you can get one if you don't. Make sure you know where it is and make sure it has good batteries. And developing nations, it's emitted from indoor biomass combustion as well, from heating or cooking. So incomplete combustion of biomass, such as wood, can create this as well. Now, the volatile organics, anything that has carbon and anything that evaporates quite quickly and creates what we would call fumes. Chemicals used in a variety of home products that easily vaporize, enter the air, irritate the eyes and lungs and bronchioles, right? These are adhesives or sealants, chemicals used to glue carpet down, hold furniture together, seal panels. We use a variety of different products that we need to be aware of, need to be more aware of. And some products we use without actually understanding their long-term effects on the human body, right? So we can be more conscious about using these products, and that's something that we'll cover a lot more in the next unit as well. But formaldehyde, common adhesive in particle board and carpet glues, or for carpet glue. So that new carpet smell is actually a volatile organic formaldehyde. Cleaners, household cleaners and deodorizers such as Febreze and plastics and fabrics can also release VOCs themselves. So we can just be more conscious about what we choose to use, and this is not something that's easy to do, but it's something that should be really done carefully. Now, radon gas is actually a naturally occurring um, form of indoor air pollution, and it's considered an indoor air pollution because it collects indoors. There's no ventilation. That's why it's always important to have good ventilation, not just for radon gas, but all of these um, indoor air pollutants build up as if remember your thermal inversion layer captures a lot of air pollution in a city. Um, Same concept. You're trapping all of these pollutants indoors. You want to make sure you have ventilation to allow them to leave, right? So, uranium decays naturally. It's found naturally in higher concentrations in some areas than others, and it decays into radon 222. All right, it can enter the home naturally through cracks in the foundation. Usually in the basements is where you'll find it because it's closest to the source, right? It can seep into groundwater as well and into the body through drinking water, and it's the second leading cause of lung cancer after smoking. If we didn't smoke, it would be the number one leading cause of lung cancer. So we need to test regularly or semi-regularly for with an airborne radon monitor, and we need to make sure that the cracks in our basements are actually sealed. And it's one of those things that people put off, but it also contributes to the high death toll or the high rate of lung cancer from radon 222. Okay, so it's an interesting one, but it's something to be very careful with. Dust and mold. Um, Indoor air pollutants that worsen asthma, bronchitis, COPD, and emphysema. Okay. Know at least a few of these diseases that are associated with each of these as well. You don't need to know them all, but know at least one. Dust settles in the homes naturally and is disturbed by movement. So keeping our homes dust free, changing our air filters regularly is important for our health. Mold itself develops in areas that are dark and damp and aren't well ventilated under sinks and showers, behind panels and walls and ceilings, and especially in bathrooms that don't have ventilation or access to like a window. Those are things to keep a really close eye on as well. Black mold itself is a class of mold that releases spores into the air, and that's really dangerous. It's especially harmful to our respiratory system. That's something that should be taken care of by professionals, but it can be removed physically by cleaning up the mold and fixing the water leak or ventilation issues that lead to this mold forming. So black mold is very serious. It's something we should be keeping our eye on. Lead. Now, found in the paint of old homes, it was banned in '78, but a lot of homes can still have lead paint. And if you have small children in the house, it's important to know how old the paint is on the features of your home. Paint does chip off the walls and windows, and it can be eaten and picked up by small children. If you had small children in proximity, you'll see that they just put everything in their mouths. I had a a cousin named Tyler who was 1.5 maybe, and he would grab a bag, carrot sticks from a bag and chew on them, and then put the carrot sticks that he chewed back in the bag and get more carrot sticks. Kids are just ridiculous. Um, and so they need to be, protected. And this is something that should be understood in your house. It can also be inhaled as dust as well. So just sanding this off, sanding off lead paint, creates dust particles, particulate matter that can carry lead into your lungs. Lead water pipes can also be release lead into drinking water, which we'll cover much more. Especially Flint is a crazy example. We'll cover that much later not much later, but in the next unit. It's less common than lead paint, but it's very common. More common than we might think. Damages the central nervous system and creates a situation we call arrested development, in which the child's brain does not develop normally, and therefore the rest of the body does not develop normally as well. And those are permanent things. So we need to be careful about that. Can be removed from the home by stripping the lead paint and replacing non-lead based paint, but please, this isn't something we just do. Please understand how to do this carefully and do your research thoroughly. And I think hiring professionals to do this is probably the safest option. And lead water pipes can be replaced by cities with copper pipes as well. This is a horrifying graph, but let's take a look here. Explain the cause for the trend in confirmed BLLs, blood lead levels around 10 milligrams per LD or DL as a percent of children tested from 97 to 2015. Wow. All right. Wow. Let's look at this graph. Total U.S. blood lead surveillance 97 to 2015. Okay, by year. That's our x-axis. We have a double y-axis, and then we have two different lines in one bar. Okay, so number of children tested is the bar. Number of children tested over here on this axis. So this blue is associated with this axis. All right, and we've tested 1,500,000 children in 97, and we see the testing of children has gone up to 4 million in 2016. Almost 4.5 in 2010, and we see this is decreasing as well. Okay, confirmed blood lead levels for 10 micrograms per DL as percentage of children tested. So we're not using this side of the axis. Blood levels as percentage of children tested. All right. So anything that is here, right? We have this dot right here in 97. We have more than 10 micrograms per DL in almost 8% of children that are tested. Okay. And then if we continue on to 1998, and this is, in my lifetime, this is scary. Right? I was growing up as well. So here we are, about 4 million children tested, or not 4 million, right? See, I'm using the wrong axis. About 1.75 million children tested. And we go over here, about 7% found of all those children tested had blood lead levels of 10 micrograms. And so we see this is decreasing from almost 8 to almost 7, decreasing over time as testing is increasing over time. So this confirms, you would think if there was nothing changing, we were testing more children, it would be percentage of children that would stay the same. But we're testing more children, and we're finding that over time, we're seeing lower and lower blood lead levels above this mark right here. And even as we go from 5 to 9, less than 10, between 5 to 9, we're seeing that number is decreasing as well over time. Why is this? Well, lead paint was identified by the EPA in 78. It was banned in 78, and so word is getting out, and people are, with new homes, have new paint that has no lead in it, and people with homes with lead paint are removing this. So we're seeing exposure to lead in paint decrease over time. Okay, go back and review. This should be a nice outline for your chapter readings, and please contact me with any questions that you may have.